Hello, and thanks for using TickBoom. This question has been sent through to me by a student, and it comes from the Board of Studies 2020 trial exam for Extension 2 Mathematics in New South Wales. So just by way of background, Board of Studies, actually the old NESA used to be called Board of Studies, and so there popped up this forum called Board of Studies, BORED, as a play on words, to kind of help students preparing for their HSC exams. I think it started maybe the year after I finished, so I never really got to benefit from it. But it does look to be a really valuable tool for HSC students. One thing that Board of Studies does is they release trial papers each year, and particularly for the math subjects, their papers are on the harder end of the spectrum. So for those students wanting to get ready for what may be some of the harder questions in their HSC exam, the Board of Studies trials are a really good resource. Now, this particular question coming from the Board of Studies paper means that there are solutions already out there, written down solutions. But the student who sent me this question, even though those solutions are available, they were still having a bit of trouble working out how to do part 2. And I think that's quite a common thing. Often in textbooks or on prior exams, you may get given a written solution, but often they may skip over steps and they might be not particularly detailed. So it's not uncommon to still not really understand why an answer is the way it is. You may have been told the what in the solution, but the why may be still a bit elusive. So what I'll do is, as I work through this question, I will try and not skip any steps, try and do it very incrementally, one little bit at a time, and so that hopefully it's clear why the result is what it is. Just to read the question, it says, an object is initially at the origin and moves horizontally in the positive direction of the x-axis with an initial speed of u. It is subjected to a resistance force such that its acceleration equation for some integer n greater than 2 is x double dot equals negative k v to the n. And we're told v is the object's speed at some time t, and k is a positive constant. So we're dealing with a mechanics question here, basically resistance in moving horizontally, which is kind of a topic that you do see in the textbooks, so there are a few things we can do to tackle this. Part 1 says show that the displacement equation is x equals u to the n minus 2 minus v to the n minus 2, all divided by k n minus 2 uv to the n minus 2. Now the student didn't have any trouble with this, but I will work through it anyway because the technique we use does help us with part 2. Part 2 says, by considering the average speed of the object from the origin to a particular positive displacement x, show that v is less than a n minus 1 on a n minus 2, which is less than u, where a n is defined as u to the n minus v to the n on n. So part 2 is the key part of this question that the student needs help with. What I'll do is when I eventually upload my video, I'll put a comment in the YouTube comments area with a timestamp so that you can just jump straight to part 2 if that's all that you need help with. But for completeness, what I'll do now is I'll work through both part 1 and part 2. So for part 1, we're told that x double dot is equal to negative k v to the n, and we're being asked to show this result of x, being the displacement, is equal to u to the n minus 2 minus v to the n minus 2, all divided by k n minus 2 u v to the n minus 2, which at first may look a bit daunting, but what we'll see is that we can get here with just some basic integration. Now the key place to start for this question, and I think with this question the hardest element of it is knowing where to start. For part 1, you need to use the result that x double dot is equal to v dv dx. Now this is a result that is not particularly hard to prove, but you wouldn't need to prove it in the context of an exam. Unless they told you to prove it, you could just take it as given. Now the reason we know it will be helpful is because there's an x in there. Because if you look at our original question, we're asked to essentially get from this result, which only has v in it, to something with an x. And the way we can get there is finding a format for x double dot with an x in it. And so that's why this one will be helpful. So therefore what we can say is that v dv dx is equal to negative kv to the n. We can bring this v over, so we'll get dv dx is equal to negative kv to the n minus 1. Because we want to isolate x, it makes sense to invert both of these. So we'll get dx dv is equal to negative 1 on k times, and there would be a v to the n minus 1 in the denominator, but to make the integration a bit easier, I'll write this as v to the negative n minus 1. Now we want to truly isolate the x, so we'll bring the dv up. So we'll get dx equals negative 1 on k v to the, and I'll just expand this, it will be negative n plus 1 dv. And now we integrate both sides. And where you need to be careful here is with the boundaries of the integral. So we'll get the integral of what is essentially 1 dx, the constant 1. And we're doing that between 0 and x. And that is going to be equal to the, I'll bring the minus 1 on k out, that's just a constant, times the integral. And we need to go, well, when x is 0, what is v? Well, when x is 0, we're told the initial velocity is u, some value u. And then at the instantaneous displacement x, we get our instantaneous velocity v. And then we're integrating v to the negative n plus 1 dv. Now, integrating 1 between 0 and x is simple enough. You'll just get x minus 0 equals x. So now we've isolated our x, which is good news. So now really we just need to evaluate this right-hand side. So we'll get negative 1 on k times, to integrate we will just add 1 to the exponent and then divide by the new exponent. So we get v to the negative n plus 2 over negative n plus 2 between u and v, which will be negative 1 on k, and I'll bring out this bit, times 1 on, and I'll write this as negative n minus 2. And the reason I want to do that is I see that we're dealing with n minus 2's in our result. And so hopefully you see negative n plus 2 is the same as negative n minus minus 2, which becomes the plus 2. And then that will be multiplied by v, and again I'll write this as negative n minus 2 minus u to the negative n minus 2. Now these negatives will cancel here, so that will become 1 on k n minus 2 times, and we can write this, these negative exponents means it's just 1 on v to the n minus 2 minus 1 on u to the n minus 2. And we're very close now, we just need to do a cross multiply. So we'll get 1 on k n minus 2 times u to the n minus 2 minus v to the n minus 2 on, both of these will have the same exponent, so it's basically uv n minus 2. And that we can see is equal to, if I just for clarity write it exactly the way we see it, is u to the n minus 2 minus v to the n minus 2 over k n minus 2 uv to the n minus 2 as required. So that's part 1 done. We've got our x, our result for x. Now if I turn over for part 2, We're being asked to show that V is less than a n minus 1 on a n minus 2, which is less than u, where a n is defined as u to the n minus v to the n on n. Now, one thing we're told is to consider the average speed between the origin and some displacement x. And that average speed would basically be the change in our displacement over a change in time. And given we're starting at the origin, it means when we're at some displacement x and we've started from point 0, then the change in displacement would be x minus 0. And again, if we're at some time t and we started from time 0, our change in x over change in t just becomes x on t. So if we can think about what x on t is, we can then start making our way towards this inequality, because it's possible to say that our velocity at any point will be less than the average speed. The average speed, yes, the velocity will be less than the average speed, and the average speed itself will be less than our initial speed. And the reason we can say that is because if you look at x double dot, we've got this positive constant k, but this negative out the front. So our acceleration is always negative, which means our velocity will always be getting slower and slower as we move through time. So basically, wherever we started, whatever that speed was, as we go further in time, the speed will decrease. So if we take the average, it must be less than where we started and more than where we got to, because we're taking the average. So what we can say is that V will be, or x on t will be between V and u. So if we can find some result for x on t that can get into this format, then we're going to have our result. Now, we just found x in part 1, so really all we need to do now is find t. And again, if we start from the point x double dot equals negative kv to the n, where in part 1 we had to use this result to find x, part 2 is actually a little more straightforward, because x double dot is by definition dv dt. So that means dv dt equals negative kv to the n, and we just want to isolate t. So just like we did before, we'll invert them, so we'll get dt dv equals negative 1 on k v to the negative n. We'll bring the v up, so we'll get dt is equal to negative 1 on kv to the negative n dv. We'll integrate both sides, so we'll get the integral of 1 dt, and we're going from time 0 up to some point time t, is equal to negative 1 on k times the integral. Now when t is 0, our velocity is u, and at time t, we're told at some time t, our velocity is v. And then we'll go v to the negative n dv. Just like before with x, this will simplify to t minus 0 equals t, equals negative 1 on k times the integral. Now v to the negative n will become v to the negative n plus 1 over negative n plus 1 between u and v. And it's a very similar set of steps to get to a result for t. So it will be equal to negative 1 on k times 1 on negative n minus 1 times v to the negative n minus 1 minus u to the negative n minus 1. These negatives will cancel, so it will be 1 on k n minus 1 times 1 on v to the n minus 1 minus 1 on u to the n minus 1. I might turn over here. So we've got t is equal to 1 on k n minus 1 times, and here we'll cross multiply, so we'll get u to the n minus 1 minus v to the n minus 1 over uv to the n minus 1. Very similar to before, to what we did with x. And then just to write this in full, we get u to the n minus 1 minus v to the n minus 1 over k n minus 1 uv to the n minus 1. And we see that this result for t is very similar to the result for x, except where we had n minus 2's, we've now just got n minus 1's. And given what we're ultimately trying to solve is something with an n minus 1 and n minus 2 in it, it looks like we're getting pretty close. So now what I'll do is we'll work out x on t. So therefore we can say x on t is simply our result for x, which was this. So u to the n minus 2 minus v to the n minus 2 divided by k n minus 2 uv to the n minus 2. So divided by t is the same as multiplying by 1 on t, so I'll invert this. So we'll get times k n minus 1 uv to the n minus 1 over u to the n minus 1 minus v to the n minus 1. So now we want to simplify this to get it into a and n minus 1 and a and n minus 2. So first we can see we can cancel these k's. The uv to the n minus 1 divided by uv to the n minus 2, that exponent will eventually become n minus 1 minus n minus 2, which would equal n minus 1 minus n plus 2. Negative 1 plus 2 will just be 1. So we're just going to have a uv out the front here. And then that's then going to be multiplied by n minus 1 on n minus 2 times u to the n minus 2 minus v to the n minus 2 over u to the n minus 1 minus v to the n minus 1. Now if I think about what our a n is defined as, if a n is u to the n minus v to the n on n, which is what we were told, then that would mean a to the n minus 1 would be u to the n minus 1 minus v to the n minus 1 on n minus 1. And a to the n minus 2 would be u to the n minus 2 minus v to the n minus 2, all divided by n minus 2. And you can see these ingredients are all here. So actually we are going to get this x on t to have our an minus 1 and an minus 2 in it. And I can see that the n minus 2 is going to be on the numerator. So what we can say is x on, well actually I'll just do it, I'll work through it step by step to make it crystal clear. Let's start by saying what is an minus 2 on an minus 1. What is that? Well, that's going to be equal to u to the n minus 2 minus v to the n minus 2 on n minus 2 times 1 over a, because we're dividing by n minus 1, so given its ratio, we times by 1 over, so it's times n minus 1 u to the n minus 1 minus v to the n minus 1, which is equal to n minus 1 over n minus 2 times u to the n minus 2 minus v to the n minus 2 over u to the n minus 1 minus v to the n minus 1, which is exactly this here. Now the reason I knew to put the n minus 2 on the top is because I could see the top of n minus 2 was the same as the top here. So that's kind of how I knew to take that punt. I mean, if I was wrong, I could have just reversed them and hopefully got to the right point. But you can save yourself that little bit of time by just noticing what you're dealing with. Therefore, what we can say is that x on t is equal to uv times a n minus 2 on a n minus 1. Therefore, we can go back to the inequality we've just worked out, and we can say v is less than uv a n minus 2 on a n minus 1, which is less than u. Now we're very close, but we're not actually exactly there. The ratio is actually reversed. So the question is, how do we get there? And I think the easiest thing to do is take this part of the inequality first, and then take this part of the inequality. So if we start with v is less than uv a n minus 2 on a n minus 1, we can cancel our v's and bring over the u. So we'll get 1 on u is less than a n minus 2 on a n minus 1. And just since I'm running out of space, I'll just write that over here. We can then invert both sides. So we'll get u is greater than a n minus 1 on a n minus 2. So that's the first part of the inequality dealt with. And we get this bit, which is this part here. So that's good. And hopefully you can see we're going to get the next part as required. So the next part is that uv times a n minus 2 on a n minus 1 is less than u. That's this bit here. So like we did before, we can cancel the u's, bring the v over. So we get a n minus 2 on a n minus 1 is less than 1 on v. So we invert both and reverse the sign. So a n minus 1 on a n minus 2 is greater than v. So therefore, if we combine these results, what we'll get is v is less than a n minus 1 on a n minus 2, which is less than u, as required. That is exactly what the question asked us to solve or to show. So there you have it. Hopefully you can see why I took the time to work through part 1. That integration technique that we used in part 1 was exactly the same integration technique we had to use in part 2. The key was just knowing, it's almost easier in a way, knowing that we can just start from dv dt and then isolate t. I think from there, I guess the harder part of this part 2 was just going, well, what is the average speed? Going right back to first principles and saying, well, it's the change in displacement over change in time. Because we're starting from the origin, that simplifies to just x on t. The average speed must be between the instantaneous velocity and the initial velocity because of the way our acceleration is operating with this negative. I think that is the conceptual key to then be able to draw this conclusion. Once you've got that conclusion, it's just a mechanical exercise of going through the algebra and not making a mistake. And I think it's possible to maybe make some mistakes once you get here. In terms of this uv being there and reversing the signs, you just got to be very careful and work through it one step at a time. Often when you're dealing with inequalities on both sides, it helps to just deal with one part at a time and then combine them later. So there you have it. Hopefully that's all made sense. Quite a bit of work in the end. As I mentioned, mechanics, they can be really tough questions. So this one I think was definitely on the harder end, but that's no surprise given it's in the Board of Studies trial. But hopefully now, having seen a very step-by-step explanation, you can see that once you kind of work out what you have to do, it's somewhat straightforward as long as you don't make mistakes. So hopefully that gives you some comfort. You know, with enough practice, hopefully you get to see enough questions like this that then if you're eventually facing it in an exam context, you kind of know what to do. So there you have it. Tick boom.